Yeah, hello everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into the cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
ఆయన ఏందో ఆయన డిపార్ట్మెంట్ మీద పగబట్టాడు.
Alright guys, good afternoon. So let me share my screen with you guys and then we can start formally. Right. So just a confirmation from participant side. So are you able to see my Jupyter notebook? You are able to hear me properly? Just give me quick confirmation guys from participant side and then we are good to go. We can start. Hi guys, good afternoon everyone and welcome back to series of machine learning and AI. So guys, quickly give me confirmation participant side and we can start the session then. Okay. Thank you, sir. Professor Ranjit Shinde, sir. Thank you. And let's get started then, guys. So, guys, topic for the day, what we're going to start with today is first topic, we'll understand the gradient descent algorithm. This algorithm is very, very important, guys, because this is the heart of the entire machine learning. All right. So, when we talk about the gradient descent is the algorithm, guys. This is the algorithm which is responsible, all right, which is responsible for the learning. Okay, it is responsible for the learning. I can say. So whatever algorithms are there, all ML algorithm, data science algorithm, they try to learn using the gradient descent algorithm only. That is the base. So before we deep dive and try to start the topic for the day, so which is our algorithms today for the day is logistic regression. Logistic regression we're going to start. And then we're going to discuss the decision tree and random forest. So we'll try to cover random forest as well. So it is a similar concept. Guys, before we start, and very, very interesting topic and very nice topic, which is called as gradient descent and which is the heart of everything, like I said. All right. So before we start, guys, anyone aware, have you guys ever seen this kind of a diagram, this 3D diagram, something called as gradient descent? So participant side, so if you guys can please quickly tell me, like if you guys are seen aware of this kind of a things and have you ever understood what is this and how this 3D diagram going on, what is working? Any idea, any fantastic idea? Have you guys ever seen this kind of a diagrams ever before in stats, before in algorithms, right? Do let me know, guys. Do let me know your thoughts and we can start understanding this algorithm. So most of us had excitement that what exactly is happening, what is that black box, what is doing in the background, how these algorithms learn, what they happens and how they are come up with this kind of a things, right? This is what the interesting part out here. So let's start with this exciting part. So try to uncover this, unbox this, the entire mechanism which is called as gradient descent. All right, guys, before I start, like I am asking, have you guys ever heard of gradient descent? Or any clues, any ideas? What is your understanding about the gradient descent? What do you mean by gradient descent? Have you ever heard of this thing? Or what is your entire thought process about this algorithm and all? So let's share some thoughts, guys, from you. I would like to hear before we start. Yeah, guys, quickly, who would like to share their thoughts? Please tell us like what do you know or what do you mean by gradient descent? Have you ever heard of this kind of a diagram? All right, let's see who's answering us today. No, guys, never heard of this algorithm? Never heard or what this denotes entire thing? Any clues? Any ideas? right? So let it be, guys. Let's okay. If you guys are not heard of it, it's okay. So we'll try to understand. Like I said, this is very, very important topic. This is the heart of everything. And whatever algorithms are there, whatever machine learning, data science algorithm, even the artificial intelligence algorithm, ANN, artificial neural network, they try to use this similar thing to uncover or to understand or to perform the learning. Right? All right. So let's get understanding. Let's get started. Let's try to understand this algorithm first. Right. So right. Any questions, guys? Any doubts as of now? Let me check the chat box if you guys are asking me anything. All right, no, right, as of now. All right, guys. So let's get started. So the guys, this gradient descent, like I told you, this is the algorithm which is responsible to find out, okay, or responsible to find out the learning or to perform the learning for the algorithm. Now, when I talk about regression equation or when I talk about the machine learning equation, obviously we had this equation, which is a straight line equation, which is equal to y equal to mx plus c, right? And we guys already know that y is our target variable. Y is our target variable. X is our feature. X is your features. So X is not single X, it is the entire vector of the X, right? So multiple could be features available. And this X was given to me. This X is the input, which is already given to me. And my main problem, my main understanding was here is how I can find out the optimal value of C and M, which is called as something called as slope intercept format, right? Slope intercept format. And this is my actual problem when I try to do a learning, right? So my main focus out here is to find out how can I reach to the near reality, or how can I reach the prediction which are very robust and which are very close to the reality. That is my question out here, right? So that is why they decided that they will use something called as gradient descent, and this algorithm works very well, very well. And this is the implementation, guys, which you are able to see this one 3D diagram, and we'll try to understand what is going on and how they are able to find out the value of M and C and what is the entire working algorithm, what is the mathematics behind this algorithm. So let's try to understand. So let's say gradient and descent. Okay. First try to uncover what is this gradient, what is this descent. So let's understand this one. Gradient. Gradient means what? What do you mean by gradient and what do you mean by descent actually? So let's imagine this way. So if I take any 2 points, any random 2 points, A and B, this way. Okay. And when I'm trying to implement any function, let's say f of x, any function between these 2 points, okay, let's imagine this way. So if I'm trying to take any variable, any 2 points, any random points, and I'm trying to apply any function which is called as f of x, this f of x could take any form like y equal to mx plus c. This could take like 1 divided by 1 plus e to the power x, or this could take like log of x plus c or something like that. Any format is possible. But that entire format, I'm not going into this. As of now, I'm just keeping it simple. I'm saying that we are applying some kind of a f of x function within these 2 points, okay? And when I am applying, guys, when I am applying this kind of a function, and when the values of this function, the result of this function are lying below these 2 points, below these 2 points, so this kind of a curve will be created. This curve. And when we have this kind of a curve, when we have this kind of a result, which gives us the result below these 2 points, that is called as concave function. Not concave, actually, convex function. Concave is like something like this one. So when you have a point like A and B, and whatever f of x function you try to apply, if the function's value lie above that A and B line, so that is called as concave. Concave, actually. And this is something called as convex. Convex. Now try to understand, when this concave is there, it is trying to create a cave-like shape. That is why it is called as concave. It is a curve. It is a curve. That is why it is called as concave. And try understand, guys, that when we are trying to apply this kind of a function A and B, where all the function or the values which are lying just below this function, and then what happen exactly is try to understand this way. So when I'm applying this kind of a function, guys, so let me change the color and tell you like exactly what is happening. So at that point, guys, at the bottom, there will be one point which is called as 0 point. A 0 point, and that 0 point is denoted by something called as global minima. Global minima. Okay. Global minima. Now you will obviously understand and ask me the question that why you are teaching this kind of things to us and what it has to do with our algorithm, with our MNC. This B is like understand C, MNC, and we are trying to find out MNC. Let's imagine this way. So let's understand this way. So what I told you that whenever I am trying to apply any function and that function's value result lies between below that values A and B values, and that is called as convex function, and this look like this one. Now why this is called as descent? Now try to understand. Since the point 0 point, the 0 point out here is in the bottom, this bottom, and this is called as global minima 0 point. Now try to understand, if I want to reach to a global minima 0 level, what I have to do here in this function, I have to come down. Like it is similar to like we are trying to climb down the hill, right? We are not climbing up, we are coming down the hill, right? We are coming down the hill, and this kind of action or this process coming down the hill where we have our target 0 value. So that is called as descent, guys. That is called as descent. This activity is called as descent, right? Descent. So that is why the name descent has been adopted. Now, cool. Everyone understood why the descent approach has been taken. Since we are using this convex function and our goal is to reach to the 0 point, and 0 point out here in this function is at the bottom. So if I were to reach to this bottom point, I have to come down, hill down, right? Coming from this hill to downwards. So that is why it is called as descent approach. Now come back to this equation, come back to the point where it is called as gradient now. So let's understand this. Why it is called as gradient and why we are trying to achieve these things and what do you mean by these things, okay? So let's understand this one. This one is I called you that this is called as global minima. Global minima, all right? So global minima point. So let's understand this one. Now what is happening? So what is my equation? My equation is y equal to mx plus c. And my objective, guys, when I taught you this regression equation or whatever machine learning algorithms are there, our objective is to find out a best fit line and in such a way that I make my function or least square method 0. Least square method 0 or in terms you can say I make my loss close to 0. That is my objective. The loss should be 0 so that I achieve a highest accuracy. So let's write our loss equation function. How the loss look like, right? Loss look like this one. Yi minus phi hat, actual minus predicted value. And I have to make this summation I equal to 1 to n. This is for all the points, square them. And my entire objective is to make them 0, close to 0, right? This loss has to be 0, then only I can achieve a highest accuracy. That's what I have to understand, right? So let's imagine this way now. Now what is happening here? My aim is to find out MNC. My aim is to find out MNC because X is already given to me. X is already given to me and I have to predict a Y. Now only situation out here is to find out MNC in such a way that my loss becomes 0. My loss becomes 0. And in order to find out the optimal value of MNC, guys, I am using something called as derivative. I am using something called as derivative. A derivative function. Now what this derivative function means? Can anyone tell me what do you mean by derivative? What exactly mean by derivative? When we try to apply the derivative, I am sure everyone heard of derivative now, right? So when we are trying to do a derivative or whenever we try to take the derivative, what exactly this derivative means? Can anyone tell me one-liner definition of the derivative? What do you mean by derivative actually? We have heard, right? We used to hate this kind of a concept, derivative integration in 11th, 12th when we learned the science or maybe in the 10th standards. So can anyone tell me like what do you mean by derivative? What exactly we do by using derivatives? Yeah, guys, come on quickly. Try something at least. Try to tell me what do you mean by derivative? Yeah, guys, any suggestion, any thoughts, any idea? So what do you mean by derivative actually? Come on, guys. Today we are supposed to interact more. So I am expecting at least some answer. Yeah, okay. Justin saying gradient at the point. Gradient at the point. Correct. Gradient at the point. So can you guys like please explain me more like when we try to understand the derivative, what exactly we are trying to find out? What exactly we are trying to find out? Why we are trying to find out the derivative means what it denotes actually, what it denotes. You guys can try and then no worries, I will help you definitely. So gradient at the point is correct answer, but exactly can you like explain in simple terms? Like when I'm trying to find out gradient at the point means what exactly I'm trying to find out in the derivative. Or let's not make it complicated. Okay, let's do this way. So when I'm trying to say I'm trying to find out a derivative, means I'm trying to find out the theta, the angle, right? Angle between two variables, angle between two things. And this is something called as slope also sometimes. Sometimes people say that we are trying to find out the slope between this, right? Slope between this. Why they are calling slope? Try to understand this way. So when I'm trying to do a derivative, guys, so derivative simply says, okay, derivative simply says that when I'm taking variable x and y and I'm trying to find out the variables, all right, rate of change. Awesome, awesome, guys. Srinivas, sir, awesome. Rate of change, the rate of change of a function of the slope of the tangent with the line. Awesome, awesome answer, guys. Sai, Lalita, yes, correct answer. Srinivas, correct answer, guys. Thank you very much. So let's understand this way. When I'm trying to find out, awesome, guys. Thank you very much for your answer. So let's understand this way. When I'm trying to find out x and y and derivative between x and I simply try to find out what is the rise. What is the rise over the run? Over the run. What is the rise over the run? So let's imagine this way. If I'm trying to say what is the rise over the run, so maybe I'm trying to put it. Let me put it in this way. Okay, let me draw somewhere. Okay, here. So when I say guys, so I'm saying that I'm trying to find out the rise over the run means if I'm saying taking x and y here, I'm saying that for 1 unit of change, 1 unit of change of x, how much change is happening in the y? That angle I'm trying to find out, that is called as derivative, and that is called as rise over the run, rise over run. When I'm trying to run this x variable, how much rise is happening? How much rise is happening in the y? That angle, that thing, that slope I'm trying to calculate, that is called as derivative, right? So cool, everyone understood derivative. And how we write a derivative? D by dx. D by dx. This is how I write a derivative, d by dx, correct? So this is what I'm trying to find out. Now coming back to our equation, coming back to our situation, that when I'm saying that I'm trying to find out the derivative, and by using the derivative, guys, I'm trying to make the loss. I'm trying to make the loss function equal to 0. Now how? Try to understand. And why it is called as gradient, and why it is not called as derivative descent? Why it is not called as derivative descent? Why it is called as gradient descent? Guys, try to understand. Even though I am taking d by dx, something like that, the derivative, but I am not writing in this format. What I am trying to do is, I have a I have a two parameters to find out, not equation actually, two parameters to find out. My main aim is to find out m and c. So now what I'm trying to do is, and I have to reduce this loss to 0. So what I have to find out, when I'm trying to change the m and c, when I'm trying to change the MNC, what is the rise? What is the rise in the loss over the run in the MNC? That is what I'm trying to find out actually. So that equation called as now gradient. Now that is called as gradient because I am taking the partial derivatives, guys. I am taking the partial derivative out here. I am not taking the full derivative. So that is why it is called this way, this derivative sign, gradient sign. Derivative of loss I am taking with respect to M, and I am taking second derivative, which is respect to the loss with respect to C. So that is why it is called as gradient. So this is called as gradient since I am taking partial derivative of loss function with respect to M, partial derivative of loss function with respect to C. And that is why it is called as gradient, not a derivative. Now I am not writing this way, d by dx, right? I am not writing d by d, right? I am writing delta by delta, right? So that is why it is called as gradient descent. Now everyone clear? Everyone is very, very well clear now why it is called as gradient descent and what is my main objective. Now you would have come to the equation, or you would have already thought about it, that what I am trying to achieve, what message I am trying to deliver out here. So my main aim is to find out M and C, and I have to find out M and C in such a way that whenever I am trying to change, whenever I am trying to do a run of M and C, what is the rise? What is the rise in the loss? That is what I am trying to find out. That's why I am taking derivative. I am not taking full derivative. I'm not taking, sir, gradient also means slope. Correct, guys. Correct. Kazi, yes, very, very, very good understanding. Gradient also means the slope. That's what I said, that whenever I'm trying to find out the gradient, so that is what I said, I am trying to find out the slope. That is why it is called as slope intercept format, right? So slope I am trying to find out actually, because I want to find out what is the change. What is the change in the y with respect to x, right? This kind of a slope I am trying to find out. So that is why we call this as a slope also. So I am trying to find out the gradient. Now my main aim is to find out M and C in such a way that my loss becomes 0, guys. That is what I am trying to find out. That is why it is called as gradient descent. Now everyone very well clear what kind of a function we are using. Now let me rub this thing and let's try to understand now. So very well, our gradient descent. Now how should actually, now you are saying, sir, you have given enough GAN, Now, but you are not actually telling us that how this algorithm will find the actual value of M and C. How should we find? Let's start the journey. Let's start the journey to find out how we can find out the M and C and how we can find out the optimal value of M and C. Now we understood we have a tool, something called as gradient descent. By using this tool, I can now achieve this purpose. Now let's understand this way and let me put it in this way. Okay. So let's this is 3D diagram. This is the 3D diagram. That's why you can see this kind of a hyperplane out here. A hyperplane, it is called as hyperplane. So you can see this kind of a hyperplane is there, right? So this is showing, trying to showcase us. This is trying to show us a 3-dimension diagram out here, right? 3-dimension diagram. So let's understand what is going to happen and how we can calculate MNC. Let's use this diagram now. So I'm using the same function. You can see here, this is the convex function I'm using. If I'm trying to draw this one out here, so this is the convex function, and you can see this red dot. This red dot is called as global minima. Global minima level, where in global minima level, my derivative with respect to loss with M and derivative with respect to C will be 0, guys, approximately 0. So this is what I'm trying to find out. So let me put it this way. So what I'm trying to do is I'm trying to create a 3 dimension now. So first I'm using this kind of a curve, which is called as convex curve, and this curve has a minima level at the 0. Now, if you try to understand, this is a 0 point. This is the 0 point. This is a 0 point, and now try to understand here is also 0 point. Okay, so 0 point, and this red dot refer to 0 point now. Okay, and let's imagine this axis now. So on this axis, guys, this x-axis, I'm trying to take M. I'm trying to take M here. On this y-axis, guys, I'm trying to take the C out here. C. Okay, I'm trying to take C. So this axis is C. This axis is C. And this axis out here, guys, x-axis is M now. So what I have to do, I have to find M and C, right? That's why I'm taking M on x-axis. I'm taking C on y-axis, okay? And this axis is z-axis. Now here I will take loss. I'll take loss out here. Now what is my main aim now? Now try to understand. So when I try to move the value of M and move the value of C in such a way that whatever this loss function is there, it should reach to the 0 point out here, 0 level. And this 0 level belongs to this global minimum where red dot. Okay, this is what I have to achieve now, right? So I have to bring this loss down in such a way that it becomes close to the 0. And for that 0 purpose, for that 0 value, what is the associated value of M? What is the associated value of C? That is what I have to find out. Now, this is what the journey will start. Now, what I have to do? Start step 1. What I have to do? So let's understand this one. I have an equation y equal to mx plus c. So x is given to me, y and c is unknown to me as of now. M and C is unknown to, sorry, M and C is unknown as of now. I don't know exactly when I'm starting first, my algorithm, when my algorithm is going to start first for performing the prediction, it is only given X. It is only given X. And I don't know exactly where is my M, where is my C. Actually, I don't know anything as of now. So how it will start now? What is going to happen? So what it will try to do? So you are providing this data. You are providing this kind of a tabular data to it. And there is one column called as Y now, and other columns are called as X now. And you are providing X, and you are saying that please try to fit this equation y equal to mx plus c and try to find out a prediction. And you guys know already what is happening in the background. So we are trying to plot our data, and out of that we try to find out the straight fit line. And this is what is going to happen, right? And but from mathematical point of view, what is going to happen? What mathematics will happen in the background? How it will try to understand how to make loss 0 and how it should find out M and C now. Now let's understand very carefully what is going to happen now and how the journey is going to start, guys. Let's understand this way. So let's imagine I'm starting at this point over here. Graphically, we'll try to understand, and I'll try to input the same thing out here in the formula, and I'll show you what is going to happen now here. So let's imagine, guys, this side, you guys know, right? Right hand side is a negative slope, and this side is positive slope, right? This side is positive slope. And then this point we started. Let's imagine this is the point. And let's call this point as AK. This is the random point. Now, how the algorithm starts now? Try to understand how the algorithm will start and how it will take the value of MNC first place. So first place, I have no clue. I have no clue what is going to happen, how to start. So what it does is it tries to take the random values first. It tries to start with the random value. What random value it has to start? Start with the random value of M. start with the random value of C, guys. This is what I'm going to start, and this is where we are starting here. Try to understand. This is the point AK, and AK means nothing but AK is denoted by this way. AK has a value of M and value of C, guys. Okay, so this is AK. Now I'm starting with the random value unknown. Since Y and M and C is not known to me, but only X is given. Now I have to substitute something. I have to substitute something, some or other thing in M and C place. Then only I will be able to understand what is going on. Right? This is my equation. This is what I have to find out. So let's understand this way then. So what I'm going to find out here. Okay. So let's do this way. So what I'm going to do is I'm going to start with the random values first. So I'm taking random value for M, random value for C. Okay. So let's put random value for M, random value for C. Let's imagine it has started with a random value. Any random value it will be taking. Let's imagine 0.5 into it will take the X, whatever X is there. Let's imagine multiple X will be there. So I'm just trying to write a simple equation into 10 and plus something called as C. So C will be like some constant, let's say 1. So this is what it has taken now. So 5% of 10 will be like 5 into 1 will be 5. And this is what prediction I should get actually, right? This is how it is going to start. So it is tied to input value of M and C. And let's imagine actually. So whatever my Y value was actually 2. Actual value of Y2. So it what going to happen in step 1? In step 1, what is happening? So I started here. I started here at the random point. And my main goal is to reach to this red point 0, where my loss is 0, and I have to find the corresponding value of M and C. Okay, this is what I have to do. I have to find out the corresponding value of M and C, and I have to reach to this global minima level, right? I have to reach to the global minima level. This is what I have to do. M and C out here, right? I have to reach to this point, and that is why I started with the random thing. And any random thing I am putting in M and C, and then I am calculating. Let's imagine whatever calculation you have done, you predicted Y hat. Now Y hat coming to 5, and when you try to compare this Y hat, obviously what is the next step you do? You calculate loss. You calculate actual minus predicted value. And let's understand this way. Actual value is 2. And now your prediction is 5. Now what is happening? I getting loss. I have a loss here. But what I am supposed to do? I am supposed to get this loss equal to 0. But I am ending with 3. I am ending up now with the 3. Means what? What this denotes? That denotes that what is this problem? I am supposed to get 0, but I am getting 3. Means what? Whatever selection I done initially, whatever selection of M and C I have done, I cannot change X. X is given to me. I cannot change X. Means only thing which is going wrong is M and C. Means whatever this random point I started, whatever M and C I have taken, those are not correct. Those are not important. Those are not correct. And I have to change. Right? So this is what I understood. This is what my algorithm will understand in first iteration. This is what going to happen in first iteration. First iteration, it will try to take M and C randomly. It will input in the formula. It will try to do a prediction. Y hat, obviously, we will get a loss. So that is why whenever you try to train your model, try to carefully look at the model. So at the model, initially, it will have a bigger loss. The loss will be very big. As the iteration goes on, your loss will get started reducing. It will get reducing. It will come towards the 0. Why? This is the reason. It takes start with the random values. It try to input in the random values. Then it will try to understand what is my prediction. It will compare your prediction with the actual value. It will calculate loss, and you will get a loss because you will not get 0. And that means something gone wrong. X cannot go wrong. X is given to me. Means M and C selection are not good. Now it has to start learning. Now the learning journey will start. It has to my main aim now. What is my main aim? Now my main aim is to do this 0 by taking the derivative. Now it will try to start taking the derivative. So it will take the derivative of loss with respect to M and derivative of loss with respect to C. And my main aim is to make this 0 now. This is what it will start. Now, what is happening on the graph side? Let's try to understand what is happening on the graph side now. So I started at this point, and this point, I started AK. And whatever AK selection I have done, MNC selection, this is not a good selection now. This is not a good selection. These initial values are not giving me loss 0, correct? So you can see here, this initial value will not give me any loss equal to 0, right? In 3D diagram also. So now what I have to do? Next thing. So let's do this way. What I have to do is now I have to calculate a derivative of loss with respect to M, derivative of loss with respect to C, and I have to find out my new values M and C. And how the new values will be found out? Let's imagine this way. Now I have to move from here. So whatever point I started here, this is not good. And my main journey is to reach to this point, red dot point 0. So I am not getting to this red point by starting with this point. So I have to do what I have to do. I have to either increase or decrease my weights. Now try to understand whatever M initially calculated, what is C initially calculated, whatever weights you have started, whether you need to increase those weights or whether you need to decrease those weights, or whether you need to increase or decrease the value of M and C, that is decided by the formula, by the derivatives. So let's try to understand this way, how it is going to happen and how it will happen on graphical side also. Let's imagine now what I have to do, whatever initial value I have started, this is not good. So I have to start with the new value of MNC. Now that new value will be called as, let's imagine this way. Now new value will be called as AK plus 1. AK plus 1. This is my new weight. I have to start. I don't know actually whether I should go here, or whether I should go down, or whether I should start here or jump to right side, jump to left side, means whether I should decrease or whether I should increase my value. As of now, I don't know this, right? So I have to use the one formula. What is my formula? I have to calculate the new values. And what is the new value formula? New value formula is this way: old values, this old value of M and C, then minus something called as learning rate, into I have to calculate the derivatives, these two derivatives, into derivative of loss with respect to M and derivative of loss with respect to C. This I have to multiply whatever the result of these derivatives are there, whatever value will be calculated, I have to multiply that value into some learning rate, and thus I have to increase or decrease. This will depend on the value of this derivative. So whatever derivative I am taking, if this derivative is positive or negative, based on that I can do a plus or minus. I will explain you how you do a plus or minus. Let's understand this way. Let me rub this thing. Guys, everyone comfortable as of now? As of now, everyone comfortable, everyone understood what is going on, how the algorithm start learning, what is the initial first step, and what is my entire goal, what is this gradient descent, how this journey will start initially. They will start randomly here and they have to reach to this global minima level, 0 level, where my loss is 0, and I have to find the respective value of M and C, guys. All right. Okay, guys. Okay. So let's understand this way. I think everyone is now comfortable, and let me rewrite my equation again. And let's understand this way. I started here. This is my loss. All right. Okay, guys. Thank you. Thanks for confirmation. Thank you, Srinivas sir, for your converts. So let's understand this way. This is M, this is C, and my entire goal is to reach here. Guys. So we can see minima level. You can see here minima level, how it is changing in this 3D diagram, right? So I have to corresponding to this value, I have to find M and C. This is what I have to start. Now I understood my equation. I have an equation also. My equation for the new value, I started here at AK. At AK, value of M and C I have taken. These are not good values. I have understood because my loss is not 0. Now I have to start with AK plus 1, new value. New weights I have to start. So how it will start? You have to take the old values. This old value of M and C, you have to take. Then I am writing something called as minus. Then I am taking one value which is called as learning rate. Then I have to multiply. Multiply by what? Because since I have to understand that what are the changes I am have to do with respect to the C and with respect to M, so that my loss is getting reduced. So that is why I am taking derivative. Like I told you, why I take derivative, because I have to find out what changes, what run I am doing in my M and C. Accordingly, what rise is happening in my L. That is why I am taking this derivative now, right? So whatever derivative, guys, you are taking here out here. So that derivative formula, let me write it this way: derivative of loss with respect to M and derivative of loss with respect to C. So this becomes my entire new formula. And by using this formula, I have to calculate my new weights or new value of M and C. So now try to understand. We started here, and whatever random values we are taken in the step 1. So I am not able to satisfy the equation, which is not able to get it to the 0 level. So I have to change my M and C, and M and C is changed by this formula. Okay, this is the formula to change M and C now. So you guys will be wondering, what is this learning rate? Now try to understand what is this learning rate. Let me explain you what this learning rate means and how it is going to affect the learning rate. This learning rate means, guys, try to understand. I started with this point, this random point. Now I have to understand. So whether I need to go to the positive side, this is negative side, or this is positive side. Means what? Whether whatever old value I have taken, my old value of M and C, what I was taken, whether I need to increase, add some value to it, or whether I need to decrease those values, right? This decision I have to take, and this decision entirely depends on the derivative. If my derivative of loss with respect to M and C is positive, let's imagine what is going to happen. So this minus into positive, what will be the result? Minus into plus, minus. So means I have to decrease. If my derivative is positive, guys, I have to decrease my values. I have to decrease my value of M and C, because this is the equation says. So if my derivative, this derivative is positive, minus into plus becomes minus, means I have to decrease. I have to initially decrease. So let's imagine I started with the 5 and 6 value of M and C. I have to decrease these values. This is what the equation says. And if my derivative, this derivative, okay, whatever this derivative is there, if this derivative is negative, okay, let me write this equation again. Okay, if this derivative, let's imagine if this derivative is negative, now what is going to happen? Negative into negative, minus into minus becomes plus, means I have to increase. I have to increase my old value. Whatever the old value I'm taken here, let's imagine this way, M and C, I have to increase those values. Why? Because same way here. So where you started here at this point, right? So where you started at this point, where this is your loss. So whenever you started, guys, then this is negative side and this is positive side. This is what I told you. So derivative will decide now whether you want to increase or decrease the old value, right? So that is why we are taking the derivative. Now, guys, what is this learning rate then? What is this learning rate? Let's try to understand. Whenever I am trying to increase or decrease, I have to make some jump, right? So let's imagine this way. I can go here, 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 I can go here. So this kind of a jump, whatever the jump I have to take. Obviously, I have to increase or decrease. That is understood. But I have to make the unit changes, right? I have to make the unit changes. How much unit change I have to do, that is decided by learning rate. So why learning rate is important, try to understand this way, guys. Why learning rate is important, try to understand this way now. So everyone is now very well aware what is going on and what is this equation is all about. So let's write this equation again. Derivative of with respect to C. Now I started with this point. Guys. Now try to understand what is my main aim. My main aim is to reach to this global minima. Right? So this at this global minima only, my derivative of loss with respect to M and with respect to C, guys, is going to close to 0. That is my main aim. So I have to come back and come down, bring down this point to this journey. And by bringing this journey, I have to understand. Unless I understand what this learning rate is playing a role out here. So what I told you that I can go to this point, I can come down to this point, I can come down to this point, I can go down to this point. So how much unit of change I should do, how much unit of change I have to do, that is decided by my learning rate, guys. Now try to understand the learning rate has to be in a very, very high range or not in the low range. Try to understand the learning rate. If you try to take a learning rate very small, now what is going to happen? So what is the derivative you are taken? Derivative multiplied by this learning rate. Let's imagine you are taking derivative like this one, learning rate this 0.001 means whatever value derivative you are getting. Let's imagine you got the derivative like 3. 3 into 0.001 means, so what is going to happen? Let's imagine this, you will end up with like this one, this value, right? So what is the old values are there? So in old values, guys, you will just making this kind of a change. Let's imagine your old value is this one. So you are making 4.001 means wherever you started here, you're just reaching to this point only. You are reaching to this point only. Now imagine if your learning rate is very small and whatever derivative differences you are getting, by these differences you are able to move with this speed. Now let's imagine if you are doing with this speed, then how much iteration I will take, guys? How much iteration I will take to reach this point? Many iteration, thousands iteration at least required. 1000 iteration will be required to such way to drop down to this global minimum point. That is why my learning rate should not be very small. Let's imagine vice versa. If I take a very large learning rate like 100. If I try to take a large learning rate 100. So let's imagine this derivative become 3. I am multiplied by 100 learning rate. So what is happened? So initially I had a value of 4. Now I am making minus 3 into 100 minus 300. So what is my value will be minus 296. So I started with 4 and all of a sudden I have to change to 296 means what is going to happen in this graph? When I started here, Now let's imagine this is what the jump will be there. This kind of a jump will be there. Now next time what will happen? From this value, again the jump will be in the hundreds. Jump will be hundreds. I will go here. 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 And what is happening by taking this by taking the large learning rate, I am trying to miss. I am trying to miss my minima point. I will never reach to my minimum point. I will always keep on jumping very high, because when I try to come down to this point, guys, whatever change I have to do here. Okay, let me rub these things again. So when I started here, when I started at AK and my learning rate is very large. Okay, so when I dropped here, from here to here, the small differences is there, but my differences, let's imagine this way 100. So again, and from here, if I try to scale down to 100, I will go here. I'll go here, I will go here, I will go here, I will go here, 100, because this difference is not 100. So I will never reach to my global minima. Never reach to my global minima. That is why I have to take a learning rate, a very optimal rate. So let me write my equation back. The AK plus 1. This is my new weight, right? AK plus 1, M and C will be decided by AK. AK is my old weight, or weight values are M and C, minus some learning rate into the derivative of loss with respect to M and derivative of loss with respect to C, guys. So this is what the multiplication I have to do with this learning rate, and this has to decide whether to increase or decrease. Okay, and this is how, guys, this is how I'll keep on doing, and this is how I have to reach to this minimum point. This is M, this is C, and this is my entire loss. I have to bring this loss to this point. So when I try to bring to this minima point, my loss will be approximately to the 0 level, and those value of M and C I have to choose, and this will happen many times. So when I started here on this convex function, when I started with this AK, guys, AK, next time I will start somewhere here based on this derivatives value. Based on this derivative value, I will start somewhere here, or I will start somewhere here, So this equation will go on, iteration will go on. Again, whatever new values are there, again I will try to input those new value into M equal to Y equal to MX plus C. Again, I will calculate my actual value minus predicted value. Again, I will try to check whether that is equal to 0 or not. If not 0, again start finding out the new value. Again reiterate. This is what going on. This way it will go on. After thousands of iteration, hundreds of iteration, I will be able to reach to this 0 point, and that value of M and C will become my optimal value, where your loss will be approximately 0. And this way, guys, my entire algorithm learns. My entire algorithm runs, guys. Understood, guys? Clear? Nice, very, very nice concept, very important concept. And how my equation will look like? Let's imagine this way. In the end, guys, when I'm trying to achieve this K plus 1, so it is like this way, or I can call this as a beta sub 0 and beta 1 also, M and C. So this will become equal to this one, this A, K, equal to beta sub 0, beta 1 minus learning rate LR into, guys, this kind of equation will happen. Derivative rate. So this derivative will be like this way, DH, derivative of loss, or you can say loss with respect to 0, and derivative of loss with respect to beta 1 also. You can see this equation, and you might also see this kind of equation where people are writing very popularly AK plus 1 equal to, let me write it in this way, beta sub 0 plus beta 1. Beta sub 0 is, guys, beta sub 0 C, and beta sub 1 is M, AK, the old value. Okay, minus this kind of a learning rate is also denoted by sometimes by this equation, and you might have seen this kind of equation also. So when we try to take the derivative, guys, derivative result will become this way, minus 2 and something called as summation of I equal to 1 to n, and this is nothing but yi minus like this way, beta 1 x1 plus beta sub 0. So let me write this way, minus 2x summation I equal to 1 to n yi minus y predicted, actually yi minus y predicted. Y predicted can be also written this way, beta sub 0 plus beta 1 x1, guys. Let me write it in better way, actually. So we can write this way, minus 2, here is the minus 2, this is the x, this is the summation sign, here is the summation sign. So here actual you have to write the difference, right? Loss. So this loss will be like actual value minus loss can be written in the terms of beta sub 0 plus let me write it in better. Okay, this here. Beta sub 0 plus beta 1 x1 this way. And this is minus beta sub 0 plus beta 1 x1. So this kind of equation you guys might also see for the change of the value of MNC, guys. Beta sub 0 and beta 1. This is K, old value, and this is your new value. Beta sub 0, beta 1, K plus 1. This kind of equation you might have also seen in some kind of a books. So this is the same thing which we're talking about. When you try to take the derivative, guys, when you try to take the derivative of the loss function, so derivative of loss with respect to M, when you try to take, so what is happening? What is loss? Loss means yi minus y hat. Okay. So yi minus y hat can be written this way. Yi minus y hat is nothing but beta sub 0 plus beta 1 x1, or you can rewrite the same equation in this format also. When you try to take the loss with respect to this M, I can write in the format of M and C also. So let me rub these formulas first and let me write it again. When I try to take the loss with respect to M and when I try to take the loss with respect to C, I can take this way or I can write this way also. So what I am trying to write is actual point minus y hat, right? And the y hat can be written as, because whatever this y hat is there, that y hat can be written this way, m1 x1 plus c, right? So this is the same thing I am writing here, m1 x1 plus c. Okay, and this I have to do summation for all the point, right? I equal to 1 to n, and this I can write in the bracket and I have to make the squares, right? So same thing I can write it here with respect to c. When I'm trying to take the derivative with respect to c, summation I equal to 1 to n yi minus this one whole square, and this is m1 plus x1 plus c whole square, right? This whole square is there. So guys, this kind of equation you have to learn. Now whatever equation I have written here, okay? So this equation taking the form of a minus b whole square. A minus b whole square, right? This is a, this is b, and this is taking a minus b whole square. When you try to evaluate, what will happen? A square minus 2ab plus b square, right? This is what the equation will happen. And whatever this equation you have taken minus ab, now you have to take the derivative of this equation with respect to b or with respect to c. And this b and c is nothing but m and c. Okay? And then when you try to evaluate, you will get that kind of a result which I have spoken as, right? So this is what the mathematics will go on in the background. And this is how it will try to follow or calculate the new weights, guys. And this is what the calculation will happen in the background. So clear, everyone? Clear, everyone? I know you have taken more time, but this is very core. There is a heart of the this entire machine learning, and you should be very well aware like what is going on. What is this mathematics? This is called as mathematics behind the neural network, or this is called as mathematics behind the entire machine learning algorithm. So this is the mathematics which goes on, and this is how the algorithm learns, guys. All right. So hope everyone now understood. Everyone is very, very clear. I know we have taken much time. Actually, we are supposed to finish this in 30 minutes actually. But since I am going too deep into the topics, so I did not care like what time it takes. So you should be very well aware what should be going on, how the entire concept look like, guys. All right. So guys, so please give me confirmation if you have any questions, any doubts, anything. So everyone okay, comfortable with this concept. So we can start immediately without wasting the time. We can start our algorithm called as logistic regression, and we can start the decision tree as well. All right. Give me confirmation, guys. Give me confirmation. Give me thoughts. So are you now comfortable? Everyone is able to understand. Any doubts, any questions as of now for any topic? Or do you find it like more technical? Do you find it like more technical, more complex? Or you find that that I am able to explain you easily? Please share your thoughts and please let me know if you have any questions, any doubts, what is going on, why we are calculating MNC, what happens, what is the background going on. So then we can move ahead, guys. Right? Okay, guys. Okay. More technical and interesting. Okay. Tara, thank you. Yeah, guys, it is more technical, I know, but that is why people call it back blocks. So it is not actually black box. It is actually this theorem which works in the background, and that is how they try to find out MNC. Because everyone must be wondering how this algorithm exactly able to find out MNC, right? This is how it find out. This is what the mathematics it does, right? All right, guys. So okay, I can get your intuition. You guys are having mixed intuition. Too much technical part to digest. I know, but this is very important. Until unless you understand this, guys, even in artificial neural network, we have a something called as weights and biases, and this is what gets updated, right? So this has to understand. You have to understand this algorithm. There is no choice, right? This is very heart of the topic. I could have easily told you in like 10 lines what is logistic regression, what is decision tree, what is doing, but no use until unless you guys understand this gradient descent algorithm. No use to understand other things, guys, because this is the heart, this is the core concept how the every machine learning algorithm learns, guys. All right. So I know I'm talking too much. Let's get started. Let me stop this window. And let's try to understand our main topic for the day. And let me share my OneNote with you guys. And we can start understanding the logistic regression now. So guys, just give me one moment and then we can start with the topic. So meanwhile, let me share my OneNote with you guys. So you guys will be able to see my OneNote, and here we'll try to understand what is this entire working of the algorithm is and how the logistic regression will work, right? So I think everyone is able to see my OneNote now. So let's start understanding this one. Now my topic for the day is like this algorithm is very simple, guys. Very straightforward algorithm is there, and let's try to understand this one. What is going to happen out here? This is called as logistic regression. Logistic regression. Now, guys, when we try to look at this algorithm, obviously what you will be able to understand is, guys, so this logistic regression equation, whatever this logistic regression is there, by looking at the name, obviously you will think that this is something related to the regression. No, guys, this is not the regression algorithm, though it can be used for regression purpose as well. But this is something called, and let me try to tell you what is this algorithm. Guys, this is one of the algorithm. This is one of the algorithm which is a supervised algorithm. Okay, it is a supervised algorithm, and it is something called as linear classifier. Something called as linear classifier. And it is trying to find out one decision boundary. It is trying to find out the decision boundary, guys. Decision boundary, something called as decision boundary. And by using this decision boundary, above the boundary, there will be one class, positive class, and below that boundary will be the another class, that is negative class. And this way, it will try to divide the data. It will try to divide the data into the different categories. Guys. Okay. Now, when I'm saying that it is a linear classifier and it is trying to create one decision boundary, what do you mean by that, and how it is trying to find out this divide the data into the categories? Let's try to understand this way. So let me show you one diagram out here. So let me put one diagram this way, and let's try to plot some data out here, and let's try to understand. Let's imagine that I have two classes out here. One class is this way. Okay, one classes are this way. And let's imagine I have one more class out here, which is like circles. Okay. So this is my two category of data. Now, what is my main aim, guys? What is my main aim out here is I have to divide this data. Okay, I have to divide this data, but try to understand. My name of the algorithm is regression, logistic regression. Now, what I said is this is a linear classifier. This is linear classifier. Okay. Linear classifier. Let's imagine my data looks like this way. More close. Okay. And some data look this way. Now try to understand, since my algorithm is called as linear classifier, what is my limitation? I have to draw only straight line. In order to create a decision boundary. Guys. Decision boundary. Now, what do you mean by decision boundary? Try to understand. If I want to bifurcate this data, guys, simply I can draw this line. The line equation will be same. my straight line equation, y equal to mx plus c, guys. Now what will happen? Above this line will be the positive class or one class, and below that line will be the negative class or one another class. Okay, and this way I'm trying to bifurcate my data this way, and this line is called as my decision boundary. Line is called my decision boundary. So this is what is happening. Now you will say, sir, this is very simple. This is very simple. This is only two category of data. Now what will happen if I have a three category data, more categories? Let's understand this way. And this is called as linear classifier. That is why I have to call, divide the data. I have to create a decision boundary only straight line. That is my limitation, guys, out here. Now let's try to understand. I have a similar data now, but the data points are like different this way. Let's imagine this way. Now I have a one more class out here. Okay, let's imagine this way. So let me quickly draw one more class out here. Actually, this was the previous two classes. And then, guys, in addition to that, let's imagine I have got one more class out here. Okay. I know my diagram is not that good, but try to bear with this one. But you are able to differentiate, right? Now, let's understand. Now, let's understand. So what I said, I have no choice, but I have to make a straight line. Straight line, but this is what called as my decision boundary. Now, can anyone tell me, like, by creating a straight line, how can I bifurcate this data now? So this is the two-dimension data. So that is why I was creating my decision boundary. Decision boundary DB was a line. DB was a line now. So when I have a three-category data, three-dimensional data now. So, but still my equation has a straight line equation. So what I can do, guys? Can anyone tell me? Have you guys studied any kind of a straight line equation or straight line shape which can bifurcate the 3D data? Any suggestions? Anything, guys? Any clues? What is the form of the straight line which can divide the three category of the data? Can't we have one more than one boundary? No, guys, that is the problem actually. So what I have to do is I have to create a straight line only. I have to create one straight line only by creating that straight line. And that straight line can take any format of the straight line. Okay, that's what I was asking. Have you guys ever studied the geometry? In geometry, did you guys find out any concept that this straight line is taking some kind of a forms, some kind of a form? That form we can use here actually. I was looking for that word actually. Okay, I'm looking for that word that when we have a three-dimensional data, how can I fit a straight line? In what kind of a geometric format? What kind of a geometric format I can fit this line, and I to bifurcate this data, guys. Come on, guys, think fast, think fast. So what is somewhere around in your mind, it will be there, but you like when I will tell you, you laugh, guys. I already know this thing, right? So think about it fast, guys. I will give you 1 minute. So we have to cover most of the topics also. So let's try to understand fast. So what kind of a straight line equation, what kind of a geometry form I can create, which is also a straight line, but I can bifurcate this data. I can bifurcate 3D data, guys. Anything coming to your mind, guys? Anything coming to your mind? Come on, fast. And anything, don't worry, don't hesitate, like you will go wrong or right. Doesn't matter. Try to come up with the suggestion, guys. Fast, come on. What could be the suggestion? What could be the form? Have you guys ever tried to think about this form? Geometric form? No? Should I will be the winner then? Can I go ahead then? All right. So guys, that is called as now plane. Have you heard of plane? Plane, guys, plane. So plane is something like this way. Plane, right? This is called as plane, guys. This kind of a shape is called as plane, and this is called as plane, guys, and this also have a same equation, just like the straight line. Just as a straight line. If I try to create this kind of a plane out here, guys, try to understand this one. If I try to put this kind of a plane out here, guys, what will happen? So above this plane will be one data, below that plane will be one data, and this side will be one data, guys. So this is how I can bifurcate, guys. And when we have a more than 3 dimension, so we obviously will ask, like, when we have a more than 3 dimension, I have to create a hyperplane, guys. I have to create something called a hyperplane, and let me show you the diagram. Let me stop sharing this and let me share my entire screen with you guys only. So it will be easier for us to navigate between the screens. So let me share my entire screen now. Yes, you guys are able to view my screen, right? So this is what I was looking for actually. So let's understand this way. So this is called as hyperplane now. Let's understand how the hyperplane looks like. Okay, and you can go back and search. This is also kind of a straight line equation only. Okay, hyperplane. So see this, guys. This is what I was talking about actually. When you have a 2-dimension data or more than 2-dimension data, I can create this kind of a plane. This is called as plane, guys. You are able to see, guys, everyone is able to see my entire screen. Just quickly give me a confirmation. So I'll not change my settings. So you can call this, guys, you can call this kind of a things is called as hyperplane. All right, guys, thank you for this one. Thanks for confirmation, guys. This is called as plane now. This is called as plane. Now when I have 2D data, 3D data, this is sufficient for me. Let's try to understand hyperplane. Let's try to understand what do you mean by hyperplane now. So how the hyperplane will look like, and how the hyperplane how the hyperplane, guys, this way. Okay, try to understand. This is called as hyperplane, guys. Okay, and what is happening this way, there will be one data set, here will be one, here will be one, here will be one data set. Okay, so this is called as hyperplane. So this is kind of a straight line equation. Only by using, I can create a multi-dimensional, more than 3-dimensional data I can classify, guys. Okay, so this is what going to happen in the logistic regression. So we have to fit this kind of a hyperplane, or you can look at the other diagrams always for the hyperplanes. Okay, so you can see this one diagram. When we have a multiple dimensions, so we have this kind of a hyperplane, complex diagram, guys. All right, so this is what it is going to take, and this is what it is going to happen, and this is how it will bifurcate the data, guys. Now this is okay, guys, this is okay for me. Now try to understand. I will give you one real-time example. Now let's understand one real-time example. Now you have to tell me the solution. Okay, you have to tell me the solution. Let's imagine, let's take some examples, some names. Let's take who. Let's imagine this way. Srinivas sir, are you comfortable if I take your name? Srinivas sir. So just give me confirmation if I take your name, you are comfortable. So you don't have to do anything. You just have to play with me this thing and try to come up with the solution. You have to try to come up with the solution. Okay. So just quickly give me confirmation, sir, if you are okay if I take your name, and then we can go ahead and try to understand. Or when you go past, sir, anyone, please tell me. Let's imagine this way, guys. Okay. So let's imagine that I am now making this this kind of a website. Let's imagine just like the Amazon. Just like the Amazon, I'm creating let's say Amazon. Any name, Amazon. This is my website, guys. I'm a competitor. I'm a competitor to Amazon now. Now my main aim is, guys, whenever you try to log into this Amazon website, let's imagine this way. What I have to do is, when I'm going to this Amazon website, so this is my own website, and now we are owner, and now my partner is Venugopal sir, and my partner is Srinivas sir. Okay, so this way. Now what I have to do is, my main aim, guys, my main aim is, whenever the user comes in, whenever the users are logging in, right, whenever this kind of a multiple users are coming to our website, this user, what they have to do is, they have to look at this data front page, home page. They have to design the home page. And what we have to do is, guys, I have to create this home page in such a way that I will be able to display my articles. I will be able to display my articles in such a way that I will try to maximize my profit. I can maximize my profit. Okay. So this is what we have decided, and we are trying to create a replica just like the Amazon. We are a competitor now. We have started the startup. Now my main aim, guys, my main aim here is, I will try to showcase such a product that people will usually, the users will try to buy immediately. So guys, can you tell me, like, whenever I am trying to create this kind of a situation, so I am trying to display this kind of a product where by looking at the product, people should be able to buy it correctly, right? Buy it at the moment I try to see or try to look at this product. So whenever any website is there, e-commerce website, how they try to display these products, guys? Any idea, any parameters, guys, you can think of, right? So what kind of a parameter I will be using? What kind of a condition I will be using to display this product, guys? What kind of a products I will try to display? What category of products? Anyone, any idea, right? Discounts. Awesome, ma'am. Awesome, ma'am. Discounts. I will try to showcase like discount. The discount will be shown like highest discount wise, right? Discount, higher discount percentage. What else, guys? What else? Try to think from the commercial point of view. What else should I display here? What kind of article should I display here so that the people will try to trust those articles and take this offers? Awesome, offers. Correct. Guys, but you are trying to Priya ma'am, yes, correct. Aisha ma'am, correct. But you guys are missing one important thing. Filter wise. Awesome. Filter wise, I try to create a filter, and in filter, guys, I try to create a, and then try to think, guys, when I'm trying to create a filter, or whenever there is a home page I'm trying to showcase, what kind of a things I will try to showcase? I will try to showcase some top 10 items. Correct. You guys are forgetting this main logic. that whenever I try to showcase this product out here, I try to showcase some top 10 product. Let it be any category, fashion category, electronics category, mobile category. Let it be any gross hold possible category. Whatever discount, whatever offer, whatever category I'm giving, I will try to show you top 10 products. Whenever try to imagine or try to go this advertising and clear content. Awesome, awesome, guys. So let's imagine my whatever things I have to show is I have to show top 10 products. Top 10 product by what? Top 10 product by the users. By the users. By the users. These are the top 10 products which are given by the user. Now imagine in this case what I have to do. Obviously, I have to classify my products. I have to classify my. Now why I'm coming? Why I'm telling this? Because I'm coming back to my classification problem. I have to classify my products in such a way that I am able to create a ranking. I am able to create a ranking for between 1 to 10. Top 10 product I can display. And if I try to display my top 10 product, there are high chances. There are high chances that all this product will be sold out very fast. If I try to showcase you one top product, or you try to imagine or try to go, I'm sure everyone is nowadays going to the Amazon, Flipkart, Myntra, Ajio, whatever website, Reliance, Jio, right? All this Tata Click or something, Chroma, everyone they try to show top selling product. This is today's discount. This is top selling product. Please buy. This many people have bought this product last month, right? 3,000 people, 40,000 people has bought this product, and immediately what will happen? Immediately you will fall for it. You'll go into that product, you see, oh, this is really good product. You'll buy that product. You'll buy that product. Right? This is what I mean. So guys, how the things are happening? How the things are happening? I am trying to classify my product in top 10. Now, guys, can you tell me one condition or one or two condition through which I can classify my product as a top 1 product, top 10 product? What is the condition should I take into consideration? What are the things I should take into consideration to rank my product between 1 to 10? Let's imagine you're trying to create a book. You are trying to sell a book. Let it be a computer related book or AI related books. Okay. AI related books are there and you are trying to understand, you want to publish a list of top 10, 1 to 10. Now, what kind of a condition you will consider, guys? Tell me fast. What kind of a condition you will try to understand when you are trying to publish a top 10 books? And then I will tell you like how the algorithm will work here. Okay. Come on, guys. Some suggestions like bestseller. Come on. Bestseller. Yes, guys. Bestseller. So you will try to understand what is the bestseller. Then what is the next thing, guys? What is the next thing? You will try to consider to create a ranking. Cost. Awesome. Correct answer. Cost. Bestseller. That's one more thing you should not miss, which is a practical thing. Practical. Think like a businessman. Very important aspect. Which you guys are still not covered. Correct. Bestseller is correct. Cost is correct. But there is one more important topic, which is matters more in today's days. What is that? That word I am looking for. Wow, that is the important, very most important criteria, guys. Come on, fast. Think about it. Think whenever you try to purchase online, what do you check first? What do you check first? Whenever you try to buy any product, what do you check first? This is the clue. What do you guys check first? Awesome, Priya ma'am. This is what I was looking for. Reviews. You always check the reviews. Publisher, correct? Awesome. You check the publisher, you check the seller. You try to check the reviews, guys. You try to check the reviews. You try to check the ratings by the users. Then only you product. Yes, publisher reviews you check, but you try to check the ratings. How much reviews are given? This matters more nowadays, everyone. So whenever I am trying to purchase a product, warranty and replacement, correct? Awesome, sir. Warranty replacement will come. But nowadays, what is happening? People don't go for warranty and replacement. People first thing people check on any website is whether there are hundreds of reviews or ratings given or not. That is the first criteria. Then I will try to go for publisher. Then I will try to check the warranties there. Then I will try to check what is the cost, right? These are secondary criteria. But first criteria is review, right? Ratings. What people think about this product. Then only I will try to buy this product, right? Everyone will agree to this. Now try to understand. What is happening. I have to create a ranking of the books on the basis of the reviews now. And let's imagine this kind of a reviews are coming up from the people. So let's imagine Karthikeyan sir. Given the review about this book. Let's imagine Learn AI in 10 hours. This kind of a book is there. And I want to decide whether this book is a top 10 book or not. One of the top 10 book, it becomes a not. Karthikeyan sir is saying this kind of a review now for this book. AI is in 10 hours. So he's saying this is awesome book. The sir saying this is a awesome book. So means I am trying to give a positive review. Yes, okay. Nice, very nice. So then what I will say, I'll try to look at the Shaila ma'am, sir, I don't know actually. So I will try to look at these reviews. They say this is this is a good book. This is a good book. Awesome. So I can understand this is a positive rating. Positive rating. Then third thing, Vikas now. Vikas, not Vikas. Actually, before that, Priya ma'am. So Priya ma'am says that this is a good book. This is good book. I loved it. I loved it. Okay. So now try to understand what is going on. And then the fourth comment will be from my side. That like the normal people, what they try to do, if they are writing this way, this book is good. This book is good. This book is good, but they'll say, but I will not recommend it. I will not recommend it. I will not. Now this is the problem. Now this is the problem. Everything was going very good for me. Now actually everything was going very good. Now I was able to understand. What I would have done is I would have created this kind of a things matrix here. So this is book number 1, this is book number 2, this is book number 3, and so on. All the books I would have taken. Here I would have written a words like this one: love, like, awesome, good, and then maybe recommend, not recommend, or worst book, nice book. And for accordingly I would have given a score. So any score I can give, like between minus infinity to plus infinity, I can create a score. Like for positive words, I will give a positive rating like this one, 0.5. Love is like more word, love is more word, then like is like less word, less affection, 4. And then awesome book is like 0.8, and then a good book is like somewhere between 0.4, and then nice book will be again 0.7. And this way, guys, what I'm going to do, I will summation. I'll do a summation of books scores. Book 1, book 2, book 3 scores, summation of the scores. So if it's someone write the worst book, I'll write a negative 0.5 or negative 2 based on the intensity of the word, based on the negativity of the word. And what I'm going to do, I'm going to end up with one kind of a score. And this score could be from minus negative to positive infinity, minus infinity. Let's imagine this way. Whatever your scores you are creating, this score could be from minus infinity to plus infinity. This is what going to happen. But when the people are giving actually yes or no, so this time was okay. But when people give this kind of a neutral comments, this is a good book, but I won't recommend it. Means this is something ambiguity. So what will happen now? So how can I classify this as positive score or negative score? That is the problem. That is the problem. And if you try to get this kind of a review, now how your algorithm, how this logistic regression algorithm, how it will try to classify. Now try to understand. Now in this situation, guys, when we cannot rely on scores to publish top 10, okay, to publish top 10, guys, this time to publish my top 10 list, I cannot rely on scores now, because my scores cannot be calculated here. Some ambiguity is there in the content, in the kind of a text. Now what I have to do, now what is the solution now? I cannot decide like whether this is a positive class or negative class, whether this is a top book or not a top book. I am not able to decide. I am somewhere in between. Some gray area is there. Now what will happen? Who will come and help me, and who will rescue me from this situation? Now try to understand. Then statistics says that now whenever you have this kind of ambiguity, whenever you calculate the scores and the scores are not enough to make the decision, what you have to do is you have to create a probability. There comes the probability now. There comes the probability into the picture now. So what is probability? Probability is between 0 to 1. Now what I have tried to do is, based on the scores, whatever the scores from positive infinity to negative infinity scores are there, I will try to bring them in the probability scale. Now probability scale is 0 to 1. 0 to 1. So instead of going for the scores, I will try to create a probability, and then whatever classes are there, let's say positive class, let's say negative class, and the neutral class, this kind of a classes are there. For each and every class, I will try to create a probability. And let's imagine for positive class, if whatever score I created, based on that, if I get a probability which is like 0.7, then for negative class, I get a probability like 3. And then less for neutral, I get 0.4. Now, whatever the max probability, what is this probability is there? What is the maximum probability is there? This maximum probability is 0.7. That become my final prediction. That become my final prediction of final class. And now what was my main aim actually? My main aim is to, whatever the scores I have created from minus infinity to plus infinity, I have to bring them in the scale of 0 to 1. In the 0 to 1. And that is created, or that is achieved by using something called a sigmoid function. Sigmoid function will come into the picture now, and the probability will come into the picture. The formula for sigmoid is, guys, this way: 1 divided by 1 plus e to the power minus y. and y is nothing but equal to straight line equation y equal to mx plus c, or when it is a multiple equation, that will be become m1x1 plus m2x2 plus so on and plus c. So this is what the sigmoid function will do, and this is the formula for the sigmoid. And by applying this kind of a sigmoid function, we can create a value between 0 to 1, and this is the probability, and whatever the max probability is there, guys, that max probability will become my final prediction. So that is why sometimes this sigmoid function is also can be achieved, or whatever the logic function, it is also called as logic function. By using logic function, we can achieve a probability out of this course, and we can decide the final class. That is why it is called as a logistic regression. So it is using this kind of a sigmoid function, and this is what the graph of the sigmoid function look like, guys. So whatever the values are there from minus infinity to positive infinity, that score will be brought upon the scale of 0 to 1 by using the sigmoid function. And this is how the graph look like. This is how the graph of the sigmoid look like, and it will try to adopt that score from minus infinity to 0 and put it into the 0 to 1. Whenever you try to put a value, the score value y, this y value, whatever equation value you will try to put it, guys, whenever you try to evaluate this function 1 divided by 1 plus e to the power of minus y, it will be brought into the scale of 0 to 1, and that is why it is uses sigmoid function. It is called as logic function sometimes. That is why this equation is, or this entire algorithm is called as logistic regression. Guys. Clear now, everyone? What is going on? What is this logistic regression? And I gave you real-time example also. When we have this kind of a class, we try to calculate using a linear boundary, decision boundary. And whenever we have a multiple dimensions, so we create a plane or hyperplane. This line will become plane or hyperplane. And but when we have this kind of a equation or this kind of a situation where I'm trying to create a classification based on reviews, based on the text data, based on the things, then I have to create this. The scores are not enough. I have to bring them in the cases of the probability between the scale of 0 to 1, that is achieved using the sigmoid function, which is this formula 1 divided by 1 plus e to the power minus y, and y equal to mx plus c, or m1x1, m2 x2, and up to c. And by using this kind of a graph, I can achieve the probability. Whatever the max probability is there, that max probability out of all the probabilities for all the classes, this will be class 1, class 2, class 3. For every class, we'll get a probability. Out of that probability, whatever the max probability we have, that max probability become our final prediction or final class or final category, guys. All right. So everyone comfortable? Everyone understood? So what is this logistic regression, and what are the two angles, and how we try to bifurcate the classification? Any doubts, guys? Any questions as of now for this one? What is happening? Just give me the confirmation. Everyone is comfortable with the concept. So we can go ahead and try to understand. All right. Okay, guys. Thank you for the confirmation. Okay. Okay, guys. Clear. Thank you. Venugopal sir, thank you. Kazi ma'am, thank you. Kazi Bashu, thank you. So guys, try to understand. This we have understood the entire working, how the logistic regression works upon. Now is the next thing. What I have to understand in this algorithm is, how can I do a performance evaluation? Performance evaluation of the algorithm. Now this is the entire working of the algorithm. But how can I analyze? How can I analyze my algorithm, whether my algorithm is doing good or bad? Whether my algorithm is doing good or bad, that I have to understand now. Okay. So for that purpose, guys, the famous concept now coming into the picture. And that is called as confusion matrix. Okay. So that is called as something called as confusion matrix will now come into the picture. And let's try to understand what this confusion matrix is all about. And before we try to understand this one, so let me write a cost function. The cost function out here. Like in cost function for the regression is like this way, right? Yi minus y hat. And this is the summation for all the points. I equal to 1 to n, and then I have to do a square. And this is the summation of the loss. That is why it is called as cost now, right? This is what the cost function is there for the logistic regression. For linear regression. And for linear regression, guys, we have something called as R score. Something called as adjusted R score. And something called as now MSC, mean absolute error, or something called as RMSC. So these are my indicators. These are my parameters using which I try to understand whether my algorithm is good or bad. Good or bad, right? Now let's try to write a cost equation. So cost equation for logistic regression will be guys this way. So this will be like this one. If P is my probability of class 1, okay. So P log P minus 1 minus P will be another class probability, another class. Okay. 1 minus P log 1 minus P. This is what it's gonna look like. Let me rub the other things out here. Okay, so this is gonna be the cost function. Let me write it again, complete equation. So this is what the P is the probability for class 1 and 1 minus P will be the probability for class 2. And this is going to be the summation I equal to 1 to, let's say, M. And then this is divided by average minus 1 by M. So this is my cost function look like, guys. This is how my cost function look like. And this is how it will try to calculate the loss or cost in the logistic regression in the classification algorithm. This is called as binary cross entropy function. Binary cross entropy function. Okay. So in case of the multiple guys, this equation will keep on adding. So P probability P 1 minus P plus there will be Z probability. So Z log Z. So this will keep on adding and this will have a sparse categorical cross entropy function. It will be called as in case of the multi-class classification. And this is how the cost will be calculated, guys. Okay. So once we understand this, let's try to understand our famous topic by using which we can understand the entire algorithm performance called as confusion matrix. Confusion matrix, guys. All right. Confusion matrix. Now, how to create a confusion matrix? Because I know for most of us, the confusion matrix is very confusing. And how to remember this confusion matrix and what are the tricks, like how to find out this confusion matrix. On the basis of confusion matrix, guys, we have something called as, there are some parameters, something called as recall, something called as precision, then something called as F1 score, and there is the fourth point which is called as true negativity or specificity. It is called as specificity. Okay, and then something last concept which is called as ROC AOC curve. So these are the parameters, guys. These are the formulas, or these are the function by using which I try to analyze my algorithm. Obviously, there will be something called as accuracy as well. So that accuracy doesn't matter actually, but that accuracy is not very widely used. So we try to use something called as F1 score or something called as recall or precision, guys. And then when we have a multiple models, so when we try to filter multiple classification algorithm, at that time we will have something called as ROC AOC curve. This ROC means receiver operator curve. And then AOC stands for, guys, yeah, guys, any questions, any doubts, Purna, please let me know. AOC curve, receiver operator curve, and area under curve. Then. So this is AOC, area under curve, and this receiver operator curve is called as ROC, guys. So this kind of algorithm, this kind of a graph is used to decide whenever we try to filter multiple models together, guys, together at that time, which one is the best out of them, we try to decide using this kind of a equation, this kind of a curve, or this kind of a graph, guys. All right, so everyone understood how to analyze this one. Recall, precision, F1 score, true negativity or specificity, ROCAC curve, and accuracy. And this is used using the confusion matrix. First, we have to build a confusion matrix, and then we can calculate this kind of a things, guys. All right, so let's understand how to build a confusion matrix first. And I'll tell you one trick, like how to remember this confusion matrix, because I know for most of us, the confusion matrix is a confusion itself. Sometimes we try to forget the things, and let's make it very simple now. And let's try to understand how I can create a confusion matrix. Okay. So here what I can write is, here I can write a reality. Guys, any questions, any doubt, you can chat with me simultaneously. If you want to ask anything, I will explain you. Okay, you can go ahead and ping me in the chat box. And let's here understand this is called as model assumption. Or model result or our model assumption. Or our result given by our model. Okay, result given by our model. Guys. Okay, let's try to understand this one. Let's try to understand this one. And let's try to fill this way, guys. Okay. So let's understand what do you mean by confusion matrix and how to create a confusion matrix. So let's imagine this way. In reality, this is 1 and this is 0. In reality, this is 1, this is 0. And for the model assumption also, this is something called as 1 or something called as 0. So this means positive and this means negative. Okay. So this one is also positive and this is called as negative. Okay. So this is what I have to understand. I have to compare vertically. Vertically, guys, it is called as reality, real time. What is the situation? And this is called as model assumption. What our model is giving a predictions or prediction. Now our prediction are compared with the model reality, and then we'll try to understand whether our algorithm is giving good or bad ideas, right? Good or bad, and how it is trying to perform the things, guys. That is what called as confusion matrix. Now, in simple terms, very simple terms, this is what is called as confusion matrix. Now let's try to understand what is this confusion matrix, how to create this kind of a confusion matrix, and what are the things which are required to create this kind of a things. Right? So let's imagine this way. So guys, meanwhile, if you have any questions, any doubt, please let me know. So we can start creating this kind of a matrix, and in 5 minutes we'll be able to finish this algorithm. So let's imagine this way, how to build this confusion matrix first. Now try to understand what I have to do is I have to create this kind of a things. My model M and versus the reality. Whatever the model M is there versus the reality, and then I will getting the result. Okay. Let's compare my model result with the reality result, and then I can fill accordingly all my confusion matrix. Let's imagine this way. Okay. So let's say that model says positive. My model prediction, my model has given the prediction as a positive class. But in reality, guys, in reality, it's also a positive class. It's also positive class. So both the matches, both the things are matching. The 1 and the 1. Model says 1. My reality also says 1, class number 1. So it is called as true positive. It is called as true positive. Okay. TP. So let me write TP first here. True positive. So let's imagine this way. Now my model says positive. But in reality, guys, it is negative. In reality, it's negative. So this is called as false positive. Okay. As this is called as false positive, I have to write this way. False positive. So when my model says positive, right? 1. But in reality, it is 0. In reality, it is 0. So it is false positive. Guys, let's imagine this way. Now my model says negative. Model says negative. And my reality, guys, my reality, it is something called as positive. Now this is my model negative, and in reality, it is positive. This is called as false negative. False negative. Then my model says negative, and reality also it is negative. So this is false negative. And when my model says negative and reality also is negative, in this situation, this is 0 and this is also 0. So this is called as true negative. Right? True negative. So let me write the true negative here. Cool. So this way I can remember like what I have to fill in the confusion matrix. So try to remember this trick, guys. Try to remember this trick. And this is the simple way. This is a simple way how I can remember like how the confusion matrix will work. So positive become true positive, positive negative become false positive. So negative my model says and my reality is positive. So it becomes false negative, and negative both are matching, called as true negative, guys. All right. So once I am able to create this kind of a matrix, then my next thing what I have to calculate is called as recall now. So what this recall says, try to understand what is the formula for recall. Guys, recall says something called as true positive divided by false negative. True positive divided by false negative. So let's imagine what I am trying to do in recall, guys. So let me write the formula for true positive. Recall. In recall, guys, I am trying to create a positivity. Whatever the positivity I've been told, whatever the positive things has been told by my model, I am trying to compare that with the reality. This is what actually happening. Let's try to understand. So how to remember this one? Let's imagine this way. So whenever I am trying to create a recall, guys, let's imagine this way. I have to create this kind of a things first. Out of this entire matrix, I have to create one kind of a vertical oval here. vertical oval on the first line here, on the first column. So what this vertical oval says, try to remember this way. So this vertical oval says this true positive, come on, this one, true positive, then true positive plus false negative, true positive plus false negative. What do you mean by this now? So let's imagine. So whatever positive told by your model, that are compared with the real-time positives, real-time positive. That is what the recall says. So whatever positive given by the model, are compared with the reality positive, compared with the reality of positives, reality of the positive, guys. This is what the you can remember, recall. Okay, so this is called as recall, guys. Okay. Yeah, guys, the attendance link is already shared. So Amar will share back again the attendance link. I have shared it again also, guys, with you guys. Okay. So guys, let's understand this is called as recall now. So what this is recall. Now, what do you mean by recall is whatever positive told by your model, whatever positive told by your model, in reality and compared to the real positives, how much portion was that? How much portion was that? That is compared by the recall, guys. Now try to understand. Next thing is called as precision. It's something called as precision. And in precision, what you have to do is the true positive. This true positive has to compare with the actual false positive. True positive with the true positive plus false positive means whatever positive told by your model. So whatever positive told by your model, let's understand this way. True positive divided by true positive plus false positive means whatever positive told by your model, how much was your model precision? How much was your model precision? How accurately your model told us that how many positives are there. So that is called as false positive. So this is what the precision says on. So whatever positivity given, so you can remember this way, this kind of a horizontal oval you have to create here. So this is the ratio we are taking, true positive as compared with the true positive plus false positive means in reality, whatever true positive given by your model, how much accurately it was able to give. That kind of a ratio is created here between the precision, guys, between the precision. Now, once we calculate this recall and precision, guys, so people like, can you guys tell me like which one is better now? Recall is better or precision is better? Which one is better and where should I use get this kind of a things? Can anyone tell me like any examples like? So where we can use recall, where we can use the precision. Precision says that whatever positivity told exactly how accurate I was to predict my positivity, and this recall says whatever positive I told in compared to the real time positive, how much was that percentage? Okay, this kind of a things are there, recall and precision. Now, can anyone tell me like where recall will be correct and where precision will be important? What situation? Any real-time situation if you guys can tell me. Yeah, the attendance link is shared, guys, okay, with everyone again, once again. Can anyone tell me, come up with a situation where we require recall is more important, where the precision is more important? Any situation, anything? Anyone would like to tell me any real-time, or let it be this way. Let's imagine this way. So let's take the example that you are doing a RT-PCR test. RT-PCR test. Okay, guys, RT-PCR test is for COVID positive, right? COVID positive here. So guys, let's imagine this way. RT-PCR test, if someone mistakenly says that false positive. So someone mistakenly says that you got a COVID. You got a COVID. Means what? You are tested positive. You are tested positive. But in reality, guys, in reality, he is not positive, but it's still this test, whatever this test he has done, RT-PCR test, it says you are COVID positive. Now what will happen, guys? Now what will happen in this situation? Is this a good situation or bad situation? What do you think? Now, apart from the panic he will have, but this is a good situation, even though he's not affected. Our test says he's positive. So means what will happen here? The impact will be not that strong. The impact or the situation, what he has to face is not that serious. He will still, what will happen? It is a better situation. He will try to take all the precautions, all the care, and he will try to take the medicine. And end of the day, he will try to save himself, or he will try to quarantine and he will save himself. And no major negative impact will be happening. In such situation, guys, we have a more recall. It's okay. More recall because we are trying to say more positive. Even though that person is not positive, we are saying it is positive, means that at that time the recall percentage is better, higher. It is still okay, guys. It's still okay. Now try to understand second situation. If we try to detect one kind of a tumor, we try to detect a tumor in the brain. Tumor in the brain, okay? At that time, try to understand tumor in the brain. So that tumor can be benign tumor, and could be a benign tumor, could be a malicious tumor. Malicious means, guys, dangerous, harmful, or benign means no harmful, no cancer actually, no cancer. Guys, in this kind of a situation, which is a like a life death situation, at that time, guys, at that time, my precision should be very high. My precision should be very high, because what my precision says, what is the true positive, false positive, out of that, what was my true positive percentage, true positiveness. I'm trying to focus more positive, true positive should be there, less false positive should be there, right? Let's imagine in this case, what is going to happen. If I try to miss out, correctly, say true positive, what will happen? That person will die, right? There will be severe consequences if you don't try to find out the more positive. That time, guys, my precision should be very high. The precision should be very high. Okay, recall should not be taken into consideration. That is what the examples are there. Why I'm trying to teach you, because you need to understand which formula should be taken where to understand the algorithm, which situation you have to take the recall, which situation you have to take the precision, guys. And once you understand this, sometimes people say that I will end up in a situation where recall is not also good, precision also not good. I need something else. That time they say something called as F1 score. F1 score. So F1 score formula is, guys, this way: 2 into recall into precision, 2 into recall into precision, recall into precision divided by recall plus precision. Recall plus precision. Okay. So this kind of a formula is there, recall plus precision. Okay. So this kind of a formula is called as F1 score. So at that time, if you are not sure, like whether you go for recall or whether you go for precision, so you can go for, guys, recall into precision. 2 into recall into precision divided by recall plus precision. This is called as F1 score. And now what do you mean by accuracy now? Accuracy will be same, guys. True positive plus true negative divided by all. True positive plus false positive plus false negative plus true negative. So this kind of a ratio of accurate, ratio of probability, kind of a probability, true positive favorable events, true positivity and true negativity divided by all the events. So this kind of a thing is called as accuracy out here, right? So mostly people, we use the F1 score. F1 score is very important, and then according to the situation, either you can go for recall, you can go for precision, guys. Okay, go for recall or precision. Now try to understand what do you mean by specificity. Specificity is same, guys. Now you have to calculate something called as specificity, means something called as you have to calculate true negativity rule. Okay, true negativity. What is this true negative you are calculated by your model as compared to the actual reality? So that's specificity, true negativity rule. So it is called as, what is the true negative divided by true negative plus this one, false positive. Okay, this false positive, this kind of a formula, false positive. Okay? So this kind of equation is called as true negativity, guys. True negativity, right? So sometimes people want to understand what is the true negativity rule. So at that time, I can create this kind of a formula, guys. Okay. Okay. Yeah, guys, attendance link is shared. I am sharing in comment chat box again. You can refer from there. Okay. All right, guys. So these are the things. And last thing, ROC AOC curve. ROC AOC curve. So what I have to do is ROC, receiver operator curve, AOC curve. When we try to build a multiple model, try to understand this way. So these kind of things are there. So here, guys, on x-axis, we have to understand the threshold. So this is threshold, let's say 0.20, probability threshold 0.40, 0.60, 0.80, okay, something 6.8. So here is 0.9 and this is 1, guys, 100%. Okay. So this kind of 100% probability recall. And guys, here you have to take something called as let's say this way. This is true positivity and this is false positivity, guys. Okay, false positivity, true positivity. You have to take this kind of things and it will calculate automatically, guys. So there is some function called as ROC AOC curve, and when you try to build a model, you have to check this kind of things. My main aim, my main objective, guys, my main objective of this model is Whatever this false positive is there, false positive rate should be very low. The false positive should be low and my true positive should be very high, guys, very high. So this is my model's entire aim. So let's imagine we have a one model like this way, one model like this way. Okay. And out of this model, guys, I have to decide a threshold here. Let's imagine if I take a threshold of 0.6, guys, what will happen? If I take a 0.6, guys, 0.6 kind of a threshold, my false positive rate will be high and my true positive rate will be also low. Sorry, not. True positive will be also low and the false positive will be low. This is not a good situation. So what I have to do is I have to take a threshold in such a way that my true positive rate is high and my false positive rate is low, guys. Low. So let's imagine this is one model. Okay, black line, I have created one model. And this way you have to take a cutoff, guys, cutoff threshold. This is called a threshold. Threshold percentage you have to check so that your false positive, your true positives are more and your false positives are less. So this way you have to put a threshold there. Once you put a threshold, and let's imagine you have built a model. So one more model you have built like this way. Okay. Now let's imagine this is model number 1, this is model number 2, guys. So first we'll try to understand that whenever we try to put a threshold, and by using the threshold, guys, if my true positives are more and my false positives are less, that thing, that kind of a algorithm or that kind of a plot is called as ROC curve. ROC curve. So I have to achieve this good ROC curve. That is my first situation for the model for to be good. And second situation, what I have to do is whatever AOC curve is there, that area should be more. The AOC, area under curve, should be more. That model is good best model. That model is best model. So let's imagine this way, guys. Let's imagine this way. So this green has a less, this kind of a area. This green model has this kind of area, and this is model number 2. Okay, and then the model number 1 is like this one, the yellow line. So it has a more area, right? More area. When I try to plot them here, so yellow portion is more and the black portion is less, guys. So in this case, when we try to create this kind of this curve, guys, this graph is called as ROC AOC curve or graph plot. Okay, this kind of a plot will be created when we try to have a visualization of this kind of a 2.2 algorithm. Obviously my algorithm 1 is better, guys, because my area under curve is better, more, because this area is more, and then my this kind of a threshold is more and very best threshold, because this ROC threshold, my true positivity rate is more and my false positivity rate is low. So this kind of a comparison I have to create, guys, and then I have to plot this graph, and then I have to choose which model is best model, guys. Which model is best model. Okay, so guys, this is the entire thing. This is the entire intuition. And for any classification algorithm, so for any classification algorithm, you have to create this confusion matrix. You have to call this recall precision, F1 score. You have to calculate accuracy. You have to calculate true positivity, and you have to create this kind of a ROC curve, guys. All right. So this is what is called as entire performance evaluation criteria for any classification algorithm. Any classification algorithm, you have to create this way, right? All right, guys. So this is the entire intuition. This is the entire intuition of the logistic regression. So let's make a code walkthrough. I thought we'll start with the decision tree. So we'll try to correct this. We'll try to start this decision tree tomorrow. Like within half an hour, more than sufficient. Decision tree in the random forest. And then guys, we'll start with the artificial neural network as well. All right. Okay, guys. I'm sharing once again in the chat box the attendance link. So please go through it. For everyone I have shared. Right. So guys, let's make a code walkthrough now. So any questions, guys? Any questions? Any doubt before we start a code walkthrough? Any questions? Any doubts for anyone? So we can make a 10 minutes code walkthrough. We still got a 10 to 12 minutes, and then guys, we can end up today's session, and we'll try to understand other things tomorrow. Yeah, guys, please let me know if you have any questions, any doubt, or just otherwise give me confirmation. You can go ahead then, and we can start a code walkthrough then. I'm sure you guys are able to see my screen, right? The Jupyter notebook. Okay, guys. So okay. Thank you, Shaila, ma'am. Sir, thank you very much for confirmation. So let's get started, guys. Let's make a code walkthrough now. How I can build a logistic regression model now. Okay, so let's try to understand this way. So what I have to do, guys, now let's the similar way. My entire process flow will be same, guys. My step one, always whenever I try to build a model, my step one will be same, guys. In step one, I have to import all the necessary libraries. Import all the libraries which are necessary to make the entire things correct, right? Okay. So first I am importing my pandas, numpy. Then I told you already why we require a standard scalar. Then guys, I am creating something called as logistic regression. You guys already know lasso regression, bridge regression. So I am creating my logistic regression model also. I am trying to import that from SQL library. I am importing my standard scalar for doing the scaling part for the standardization or the normalization for my model. And then pandas and numpy for the pre-processing, guys. And then you can see here, guys. You can see here. So I am importing various inflation factor, VI score to check the multicollinearity. So don't forget to check the multicollinearity as well. And then guys, there you don't have to create this kind of a confusion matrix, ROC, AOC curve and everything. There is a direct implementation given in the SQL matrices. So you have something called as confusion matrix, or you can create a classification report also. Classification report. There is a classification report. There is a function called as classification report, guys. So you try to import that report from the SQL library, and it will try to calculate everything for you. It will try to calculate recall, it will try to calculate precision, it will try to calculate F1 score, it will try to create an entire confusion matrix, and it will try to show you the accuracy as well, right? So you don't have to manually calculate, but you should have an understanding how the things works. So we are creating confusion matrix. We are importing ROC curve, ROC AOC curve to create a model, understand the model and accuracy score. And obviously for the visualization purpose, we have a matplotlib, seaborn and the scikit-learn. Okay. So this is what I am importing. Then guys, try to understand what the next thing I am trying to do. Now I am trying to take a data, guys. So this kind of a data is called as diabetic data. Now try to understand what I am trying to do. So what is my target column here? Let's imagine this is my target column outcome. My target column either will be 0 or 1. Now, what do you mean by 0 and 1 means? 0 means no diabetic, non-diabetic person, and 1 means diabetic person. Okay. So this is what I'm trying to find out. And what are the X? My X, these are my features, guys. Okay, these are my features. So these are called as X, and this target is my Y now. So what I'm trying to pass, if some person goes to the pregnancies, especially for the ladies. So if they have pregnancy, how many pregnancies they have? What is their glucose level? What is their blood pressure level? What is their skin thickness? What is their insulin level? What is their BMI? And what is their diabetic pedigree function? Okay. So this kind of information I'm trying to collect for the patients from the person, and what is their age, obviously. So this kind of information I collect and I call them as X. These are my X. And once I pass this information, guys, I should be able to predict correctly whether this person is a diabetic or non-diabetic, 0 or 1. Okay. This is what the data I'm looking for, guys. All right. So this is what the data look like. So let's imagine same thing. So when we try to import the data, guys, first thing we always try to take the head, try to take the tail. We try to create whether there are any values, duplicate values, 0 values, outlier present. We try to remove them, and we try to create a cleansing data wrangling technique, and then we'll try to do a EDA, graph plotting. So that's what I'm going to do here. Try to understand here. So I'm checking a head to check what kind of a columns are there, what kind of a data types are there. Then I'm trying to create something called as descript, 5-point summary. What is my high value, max value, mean value? Okay, how my entire averages look like for all the column. And then what I can do is, guys, I'm trying to plot a distribution diagram for each and every column. See these. So now try to create a pregnancy, glucose, blood pressure. Now you can immediately come to know that this is showing this big peak. This big peak is shown. This is going above the normal distribution. Okay. This is my normal distribution. This is also a normal distribution that peak is going on. Means outliers are present. Outliers are present. Okay. So this kind of a distribution, I am trying to compare with the normal distribution. I am trying to compare check the things. Okay. Now we can also see here some values. Okay. So when I'm trying to compare this kind of a data, you can check here. The skin thickness has some values which are 0. And this data obviously peak is outliers for me. And also for here, you can check some values are 0 actually. Insulin. Some values are 0. Okay. And there is some big peak out here, right? And also this kind of a rough portion is there above this normal distribution. Above the normal distribution, right? For BMI as well. So what I'm going to do, I'm going to create this kind of remove this kind of a peaks, and I'm going to remove the 0 values as well. This is the transformation I can do now, right? So let's understand this way. So similarly for here, outcome, you can check the age, you can check diabetic pedigree function, you can check. It is not a symmetric data. Now let's do the same thing. What I'm trying to do, I'm trying to import the 0 values, replace BMI 0 with the mean, guys. This is what I'm doing. Data BMI, replace 0 with the mean value, and replace 0 with the mean and median value. This is what I've done. So first I have removed the 0 values with the mean values, replacement I've done. Then after replacing, I'm again checking the distribution, how the distribution look like. Still, I can see some outliers are present. Now I can remove the outliers. Okay. For removing the outliers, guys, I can create a box plot. Everyone aware of the box plot, right? What is this box plot? Box plot is this way. And in the box plot, guys, this is quarter. This is quarter 3. This is my median, and this is my quarter. This is the lower range, and this is the upper range. So whatever value is going above this one, or from this Q3 1.5 IQR interquartile range plus Q3. So whatever the range is there, below that whatever points are going, those points are called as outliers. So you can see here, these entire points are outliers out here. So okay, so let me show you again. So these points are outlier, these points are outlier here, these points are outlier for me. Some outliers are present in this column, and these are outliers. Immediately I am coming to some outliers are present here. So what I have to do, remove these outliers in order to fit the model first, right? So this is what I'm trying to do. See here, I'm trying to remove the upper percentile, this percentile data. I'm taking only 98%, means 2% of the above top data I'm removing. This is what I'm doing. Sometimes I'm removing top 2%, sometimes top 1% data I'm removing. And by removing this kind of a top data, I'm trying to remove my outliers, guys. This is what I'm trying to do here. And once I'm doing, then again I will plot my data and try to check now. Now we can check that somewhat smoothness has been brought and my data is looking now normal, right? So once I drew this kind of a transformation, then simply split my data in X and Y. Y become my outcome and my target, and X become all my columns, other columns, right? So I can check the other distribution graphs as well to check how the distribution look like. And obviously the next thing what I will be doing, guys, I'll try to create a transformation of the data. So some data, now we can check the data. Actually go back and check the scale of the data. So some data is in hundreds, some data is in the normal range, some data are like very well low range. Diabetic predicting function between 0 to 1 range, age are like 1 to 100 range. So this kind of a disparity is there between the magnitudes. So that's why we always have to do a standard scaler. Let it be any kind of a data, guys. It is always the best practice to a standard scaling and try to bring out that scale data, right? So this is what I'm trying to do, guys. Here I'm calling my standard scaler. I'm trying to standardize the data, bring the data into the standard scale by using standard scaler dot fit transform. I'm passing my variables, all the features. And then once I pass, that is called as X scale. Now you can check the values between 0 to 1 or brought to the small scale without changing the data or the meaning of the data. Now, once I have these, guys, I can create this kind of a thing. I can check my VIF score to check the verticality. So there is a function called as VIF, various inflation factor. I'm passing my X, and for every X in the X, right, in the column names, I'm trying to plot this data. So this is the VIF score, and this is my features name. Okay. So none of them is having more than 5. Everyone is having less than 5 values. So I am good to go. There is no multi-cardinality exists. Then what I have to do, simply try to split my data, trend test split. I'm splitting my data into 75-25. So 25% data going for the test, and the remaining good data, 75% data, I'm passing for the training, guys. This is what I'm creating here. X train, X test, Y train, Y test. 4 variables are created and trend test split. This function is called upon, and this is my ratio of the split, guys. All right. So this, once I have created this, then I'm calling my logistic regression function. And once I call this function and store in the variable log regression dot fit. This is the training method. This is the method for calling the training, and I'm passing my X train, Y train data. And once I then do this, guys, my training is complete. See here, regression. It is trying to take the class weightages. Some parameters are taken automatically. Random state, penalty. So if you want to create a L1 penalty, L2 penalty, L1 plus L2 penalty, this is possible because this is also a logistic regression. So you can create this kind of a penalty as well. Depending on your accuracy, depending on score, how your data is behaving, all these things you can decide this thing. And once, guys, once I told you, like, once we do fit the data, we do not do the prediction directly. We go for the saving the model. So I'm importing pickle library, and I'm passing my model name as model for prediction dot wb dot sav or dot pickle. You can give any extension dot sav dot pickle dot pkl, and then you are saving this file in the read write mode. And this is what you are saying, pickle dot dump. And once you dump this, guys, that means your file is saved. Then you have to load back that model. And once you load, then you have to do prediction. This is what we are doing. Logistic prediction dot predict. I'm passing my test data, guys. And now once I pass, I can check the accuracy score. My accuracy is very good. I have a confusion matrix here. Confusion matrix, I have to pass Y test and Y predict, actual minus predicted. And once I pass, I can get an entire true positive, false positive. True positive are more, false positive are less. True false negative are less. True negative are more, guys. So I can create true positive, false positive. I can create a F1 score. So precision, recall these formulas. I can manually create, or I can import those formulas also. And you can check here, my accuracy, my precision is high, 88%. My recall is also very good. And my entire thing, recall into precision. If I am not satisfied with the recall of precision, my F1 score is also doing very nice, guys. 82%. Awesome model we have created. Now what you have to do is, last time, when you are trying to fit a multiple model, you have to call something called as ROC score. So ROC score, we have false positive, true positive, and ROC curve function is there. Pass your prediction and actual value, and you can get this kind of a curve, guys. So here you can check or decide which should be your threshold. So by using this kind of a threshold, you try to limit your false positive to the less, and you try to increase your true positive. So this kind of a thing will be there. So by this probability, the false positives are less and your true positives are greater. This kind of a threshold you have to decide. And once you decide, guys, you call a AOC score, something called as AOC score. And once you call the AOC score, here is only one model bit. If there are multiple models, there will be one more model will be shown. And whatever area is more, that model is the best. So obviously this is model number 2, this is model number 1. So model number 1, area AUC area underscore is more. So this is the best model, guys. Okay. So this is the entire code walkthrough, guys. This is how the entire code looks like. And this is how we can fit a logistic regression, guys. All right. So guys, any questions, any doubts, how the things are happening, what is F1, what is recall precision, how to build a model, how to check the scores, how to calculate everything, how to scale the data, how to find out the EDA. This is called as EDA part, graphical visualization, everything, feature engineering. All right, guys. So I know we are supposed to start with the decision tree as well. So tomorrow, it will not take much time, because we have to understand the entire classification parameters also, how we can judge our algorithm. So tomorrow we'll try to finish first this entire classification decision tree in random forest. Then we'll start with the artificial neural network. Okay, in which cases recall is used, in which cases precision is used? Okay, nice question. So I will explain, guys, again. So let's imagine this way. So I told you, like COVID situation. In COVID positive test, when you do a RT-PCR test, guys, let's imagine this way. In RT-PCR test, guys, even if the person is there, so even if he falsely says positive, even though he's not got a COVID, okay, he's not affected by COVID. He's not affected by COVID. Reality is that he don't have a COVID. He don't have a COVID disease with him. But still my PCR test, RT-PCR says that it is COVID positive. What is going to happen here? What is going to happen? So even though he's declared as positive, guys, this is false positive, right? This is false positive. Even if I have a more false positive, in that case, that is called as something called as recall here. In this situation, recall. So my recall formula is, guys, true positive, which is the true positive divided with the true positive plus some formula, a true positive divided by false negative. Means this way. This is my true positive, this is my false positive, this is my false negative, this is my true negative. Okay, this formula I am trying to check, and this is called as model reality. So this is the reality actually, and this is the model assumption. In reality, what I am trying to do, whatever positive told my model, I am trying to compare with the reality. So here the recall, if the recall is more, that is okay. In this case, recall is more, this is still okay, right? Because even though I am not positive, I am told to be positive, I will try to take a more precaution. I will try to take a more precaution, and my all right, guys. So even if I try to take this kind of a things, all right, sir. So I am explaining again. Don't worry. So whenever I have a COVID kind of a situation and people mistakenly say you are positive, but in reality you are not affected by the positivity, you are not affected by the COVID, but still people declared you that you are COVID positive. This is a good situation actually. My recall is high this way. In this way, my recall will be high, guys. My true positive are more, but false positive are less. Even the true positives are less. It is okay. Even though my false positives are more, here it is not going to create me any serious problem. Even if people tell me that you are COVID positive, I'll try to take a precaution. My life will be saved. In this case, guys, you can use a recall. If the recall is more, it is okay. But now try to understand this situation. Try to understand. If you are trying to do a court case, in the court cases, guys, if you try to understand this way, in the court cases, let me write this again. This is 1, this is 0, this is 1, this is 0, this is true positive, this is false positive. Now, this is false negative, and this is true negative. Now, what is my precision here? Now, in the court cases, this kind of a situation, where in the court cases, guys, if I am found guilty, means positive. If I am found guilty, means positive. Obviously, I have to go to jail. I have to go to jail. My entire life will be ruined, right? Entire life will be ruined. So here in this case, guys, the false positive number should be very less, right? Very less. The true positive should be more. The true positive should be more. The false positive should be less. If I get a false positive, so that case, my precision should be high. What my precision says, guys, here, true positive, true positive divided by true positive plus false positive. This kind of a situation is called as precision. Means I am trying to compare whatever positive told by my model, out of that, how much are really positive. And this real positive number should be very high. This is called as precision. In this case, guys, whenever I am trying to create a code case situation, so where the if I am found guilty, in mistakenly, if even I am found positive, means false positive, this is not good. This is not good. My entire life will be ruined. This is very serious problem. This is a serious problem, right? Or kind of understand, kind of a medical situation where I am supposed to have a cancer situation in where if I someone tells me that you have a cancer, false positive, even though I am not a cancer situation, what will happen? I'll try to do lot many dialysis. I'll try to change the blood. I'll get entirely conscious. And what is the possibility that I will lose my life, right? My entire life will be getting hampered. So in that case, guys, my precision should be very correct. So if I think cancer means there should be really cancer. Otherwise, my entire life will be hampered, right? And if I was cancer, if I try to miss out, that is the problem. That's why my precision should be very high, right? And in kind of a court cases situations also, where if I am not guilty and still mistakenly someone tell me guilty, I have to go to jail, right? My entire life has to suffer. So this kind of a situation, guys, my precision is very important. My precision rate should be very high. And when I told you like COVID like situation where the even if I declare someone positive, that is not going to impact my life. So that kind recall could be more. And if you don't want to go with this situation, you have to calculate F1 score. So F1 score take the mixture of everything. 2 into recall into precision divided by recall plus precision. So this is the best accuracy method to calculate your model is performing good or bad. Alright guys, so everyone understood in which situation we have to use which formula? Any questions guys? Any doubts as of now? Comfortable everyone? Everyone able to understand? Any other questions? Any doubts? Alright man, thank you, Roshni man. Alright guys, then if no question, no doubts, we'll try to conclude our session today. I will try to continue tomorrow with the higher algorithms, decision tree, random forest, and artificial neural networks. Alright. So that's it, guys, from my side. I hope you enjoyed this session today as well. Thank you, Venugopal sir. Thanks for your kind words. And we found it really interesting because this is the base, and especially the gradient descent, guys. Especially the gradient descent algorithm is an awesome algorithm. Gradient descent. So even if you try to learn various algorithm, various books, you will not find the explanation. This is not the easy explanation given. So this class is very, very important because the class gradient descent we have discussed, guys. So this is very super technical concept. So once you understand this concept, guys, then you are very good to go with the entire concept of the AI and machine learning, guys. All right. So let me stop sharing, guys. So I will hand it over to Amar. So guys, if you have any question, anything. Yeah, guys, Praveen Raj, yes, I am sharing all my documents and all my this code walkthrough with the LMS team, and they will upload in the LMS, guys, all these things. Okay, entire presentation code and Jupyter notebook, everything will be added to the yeah, guys, it will be added to the entire LMS session, and you can download it from there. It will be available for everyone. Yeah, guys, that's it from my side. Then thank you very much, and I hope you enjoyed this today's session as well. So it was very intense, I know, very, very intense for me. Yeah, thank you, Bharti ma'am. Thank you for the same thing. All right, guys. Any other questions? Any other doubts? Anything else you guys want to discuss? As tomorrow's session going to be super technical, so we're going to start with the artificial neural network. So please be prepared. So I am going to create a very high technical concept tomorrow. Obviously, I will try to make it very simple for you guys. So please be prepared for some concept, which is really, really important to understand the deep learning techniques. So guys, that's it from my side then. Thank you very much. If no further doubts and questions, hand it over to Amar then. Yes, thank you. Yeah, Amar, you can go ahead then.
Yeah, sure. Thank you so much. So, dear professors, I already shared the attendance link in the chat box. Please mark your attendance and share your valuable feedback as well. And I'm sharing the attendance link once again. Okay, then can we wind up the session? I think everything is fine.
Yeah, I guess no doubts and no question, guys. So I think we'll conclude here
Okay,
today.
yeah, sure.